Welcome to DP Tutorials by Donny Jerva. In this teaching module, we will confabulate on one teaching lesson, which is the relation between the drift velocity of the electrons and the relaxation time. So we have learned that the drift velocity of the inside conductor, there are free electrons, and all these free electrons are accountable for the generation or for the flow of current inside the wire. So all these free electrons, when they are acted upon by the electric field supplied from the external source in the form of a battery, they will be moving towards one end of the conductor. Suppose, for instance, if there is no electric power supply or there is no battery which is connected across this wire, then all these electrons will be moving or in different direction, or what we describe as random motion. All these electrons will be moving in different direction. But the moment when you pass electric field across this wire, all these electrons will be moving in a single direction, or we define as a specified direction. So the movement of these electrons in a specified direction, they will have some kind of velocity. All these electrons will be having a certain type of velocity. So all these electrons, let Vd be that velocity. This velocity Vd is what we define as the drift velocity, And apart from that, the moment when these electrons, they are moving towards each other, if this electron is moving towards this side, that means it is certain that there will be collision between the neighboring atoms. So that time, what is relaxation time? That time spent by the electrons between two successive collision. That means if T1 is the time spent by the electron for collision with this electron number 2, and then this electron number 2 collide with this electron number 3, T2, that means there will be two successive collision. That time of T1 plus T2 is what we define between two successive collision. This is what we define as what? As the relaxation time. Also, when these electron moves, we know that electrons are small particles, they will have mass, all these electrons also, they will have what? They will have mass. And when they have mass, that means since they are in motion governed by certain velocity, they are certain to have what? It is certain that it should have force, or there should be force associated with the electrons. So using these key ideas or concepts, we will try to establish the relation between drift velocity and relaxation time. So from the description of how to derive this is that we need to consider a wire. The moment when we consider this wire, that means when you pass electric field across this wire by using this battery having a potential of V volts, that means what will happen? Electric field will be set up inside the wire. So let us consider this battery having these polarities plus positive and negative, having potential of V volts. Then the current will flow in this direction from the positive terminal of the battery to the negative terminal of the battery. This is what we define as our conventional current, and this end of the wire will be maintained at a positive potential. This end of the wire will be maintained at a negative potential. So these electrons, all these electrons, since they are negatively particles, they are negatively charged particles, they will be in motion, and all these electrons will be in the direction which is opposite to the field. Now, before the motion of the electron, that means electric field will be set up in this wire because of what? Because of the potential from the battery. So that is the direction of the electric field. Now, one end of the conductor will be maintained at the positive potential and the other end of the conductor will be maintained at a negative potential. So all these electrons will be moving, drifting or moving towards the positive end of the wire, and they will be moving with a certain velocity. Let that velocity with which the electron moves be the drift velocity denoted by Vd. So I have written over here that the electrons move in the opposite direction with respect to the direction of what? Of the electric field. Now these field electrons, they will experience a force. Okay, so they experience a force under what? Under the effect of the electric field. Now what is that for? What is that relation? Okay, that relation or that equation which gives the relationship between force and electric field is given by this expression. Okay, F equals sign the charge, okay, times the electric field. Why we have written in this in this form? Because the force with which these electrons, okay, the force with which these electrons moves and the direction of the electric field is oppositely directed. So we can write over here that the negative sign, okay, this negative sign indicates that this negative sign indicates that direction of the electric field is opposite to the motion of the electrons, is opposite to the motion of the electrons, So that is the characteristics of why we have this negative sign. We can mark this as equation number 1. Now further, this force also can be written in another format. We know that these electrons will be having mass, so we have to write this equation of force in terms of what? In terms of the mass of the electrons and the acceleration attained by the electrons. So from here, this will be force, which will be equal to 1, which will be equal to mass into acceleration. What is this A? This A is the acceleration attained by the free electrons. So when you combine these two equations, okay, we have, that means from 1 and 2, we have, that means in place of F, you can put by M into A, and over here, this will be what? This will be negative, okay? This will be negative minus E. And from here, we can write this A as minus EE divided by 1, divided by M. Okay? EE divided by M. Now we want to establish the relationship of the velocity. So we have to know, that there is a relation between acceleration and velocity. So acceleration is defined, as the rate of change of velocity, or velocity divided by time. So we can rewrite from here by using this concept that velocity divided by time is nothing but your acceleration. So we have also explained that when if these are the electrons and they undergo collision between two successive collisions, okay, this is electron number 1, electron number 2, and electron number 3, first collision, okay, then over here this will be a second collision. Then what will happen? There will be some time spent during its collision. That time is what is known as your relaxation time. So when the electrons move towards the positive end of the conductor, during certain time, they suffer collision. So over here, if tau be that relaxation time during these collisions, then we can write, this A will be equal to what? This A will be equal to Vd divided by tau, making use of this expression. Then from here we can write that, so we can mark this, okay? We can mark this as another equation. Suppose let this be equation 4. So from 3 and 4 we have from equation 3 and equation 4 we have, so in place of A we will put by this expression, Vd divided by tau, which will be equal to minus EE divided by M, which means that this Vd will be equal to 1 minus EE divided by M into tau. So this is our expression for the drift velocity of the electrons. Since velocity is a vector quantity, so we will put the bar notation. Okay? So we will put the bar notation. So that is the expression for the electric field. Okay? For the electric field, or for the drift velocity in terms of the relaxation time. Okay? In terms of the relaxation time. So this is the drift velocity and this is your relaxation time. So just go through those derivations so that you will understand the concept, and also make sure that before this collision we make use of the first equation of motion. We can make use of the first equation of motion from here. Why we are getting this equation is because we are using the first equation of motion, V equal U plus A into T, where in this case we can write as Vd, and this will be equal to U plus A into tau, and from here this U will be equal to 0. Why U is 0? U is 0 because when you don't apply the electric field during thermal agitations, okay, before you apply electric field, that means due to thermal agitations, the initial velocity of the electrons will be equal to 0. So you'll get that equation, and from here you'll get this Vd equal A into tau. So if you try to solve this, if you want to solve this, then you'll get A, which is equal to what? Vd divided by tau, which is nothing but this expression. So you are getting this from the first equation of motion. But this which I have written in this pink colored pen are not necessary to be incorporated during your examination time in your answer book. So just know that this is the logic behind. Okay, thank you.